Hello, science fans! Get ready for another exciting exploration into the building blocks of our world. Today, we're embarking on a fascinating journey to explore three essential materials that literally hold our world together, the unsung heroes of construction and infrastructure. First, we have cement, then lime, and finally, gypsum. You might not always notice them in your daily life, but trust me, they're absolutely everywhere, starting from the very sidewalks you walk on every day, all the way to the walls providing shelter and structure in your very own home. Cement, in its raw form, is that fine gray powder that, when skillfully mixed with water, carefully selected sand, and durable gravel, undergoes a transformation and becomes concrete, the strong and reliable backbone of modern construction as we know it. Lime, which is derived from limestone, proudly stands as one of humanity's oldest and most time-tested building materials, having been skillfully used for thousands upon thousands of years in both strong mortar and smooth plaster. Gypsum, on the other hand, is the key and main ingredient that makes up drywall, ultimately giving us those beautifully smooth and perfectly paint-ready walls we see in almost every home. Interestingly, each of these materials starts its journey as a simple rock, but is then dramatically transformed through intense heat and complex chemistry, eventually becoming a unique powder, each carefully designed with its own very special job to perform. And remember, they're definitely not interchangeable. Each one boasts a distinct chemical personality and a very specific purpose in the construction process. Therefore, understanding their individual differences is absolutely key to successfully building everything from the most ancient of monuments that have stood the test of time to the most modern and innovative skyscrapers. So make sure you grab your safety goggles and other protective gear, because we're now about to dive deep into the fascinating science that lies behind each of these essential materials. Our exciting journey into the incredible world of mineral binders starts right now. Let's pull back the curtain and explore how we transform seemingly ordinary rocks into extraordinary building materials. It's a fascinating journey from the earth to incredible structures. We're about to witness the alchemy of construction, where raw materials undergo amazing transformations. Heat is a key ingredient in this process. It's the catalyst that unlocks the potential within these stones. For cement, the foundation of modern construction, we carefully blend limestone and clay in precise proportions. This mixture is the starting point for a material that will bind our world together. Then we fire them in a giant rotating kiln, reaching scorching temperatures of 1,450 degrees Celsius. This intense heat triggers a series of chemical reactions, transforming the raw materials into something entirely new. The result of this fiery process? Clinker, small, hard nodules that hold the key to cement's strength. We then grind this clinker into a fine powder, increasing its surface area and reactivity. To control the setting time, we mix it with a bit of gypsum, a crucial additive. Lime production is a bit simpler, a more ancient process. We heat limestone in a kiln at around 900 degrees Celsius, a lower temperature than cement production. This process drives off carbon dioxide, a gas, leaving behind quicklime, a highly reactive material. When you add water to quicklime, it undergoes a chemical reaction called slaking, resulting in hydrated lime. This hydrated lime is then ready to be mixed with sand and water to create mortar, or used as a key ingredient in plaster for walls and ceilings. Gypsum's transformation process is even gentler, requiring less energy. We heat gypsum rock at a relatively low temperature of just 150 degrees Celsius, a process known as calcination. This heating removes most of its chemically bound water, transforming it into plaster of Paris, a versatile material. Each of these processes relies on the careful application of heat to unlock new and valuable chemical properties within the raw materials. Cement production demands the highest temperatures, pushing the materials to their limits. This intense heat is what allows cement to develop its incredible binding strength, making it ideal for large-scale construction. Lime's lower heat treatment preserves its breathability and flexibility, making it suitable for more traditional building methods. Gypsum's gentle bake, on the other hand, keeps it perfect for creating smooth, fast-setting finishes on interior walls and ceilings. Three rocks, each with its unique composition, three distinct recipes, each carefully controlled to achieve specific properties, three essential building blocks that form the foundation of our built environment. That's the fascinating science of material transformation at work. Now, let's delve deeper. and see what these seemingly simple powders are capable of achieving in the world of construction. Cement is the glue behind concrete, the stuff of cities. Mix cement with water, sand, and gravel, and you get concrete for sidewalks, roads, and skyscraper foundations. Cement also makes mortar, which holds bricks and stones together, and grout, which fills the gaps between tiles. Without cement, our buildings would crumble and our bridges would fall. It's also used in precast products like pipes, blocks, and decorative statues. Cement can be engineered for strength, speed, or flexibility, depending on the project. Its versatility is unmatched in construction. From massive bridges to tiny tiles, cement is the silent hero. It's the backbone of our built environment. That's why cement rocks. Lime isn't just for ancient ruins, it's vital today. In agriculture, lime neutralizes acidic soil, helping crops thrive. In steelmaking, quicklime removes impurities, making stronger steel. Sugar refining uses lime to clarify juice for pure sugar. In construction, lime mortar and plaster are prized for restoring historic buildings. They're breathable and gentle on old bricks. Lime also treats water, softens it, and removes impurities. Power plants use lime to capture sulfur dioxide, fighting acid rain. It's a quiet environmental hero, cleaning our air and water. From farms to factories to historic sites, lime keeps things balanced. Ancient, but still essential. Gypsum is the star of drywall, the panels that make up most interior walls and ceilings. It's fast, easy to install, and creates smooth surfaces ready for paint. Gypsum is also added to cement to control setting time, preventing flash set. In agriculture, gypsum improves soil structure and provides calcium and sulfur for plants. It's even used in food, making tofu, firming canned veggies, and conditioning dough. Gypsum helps brew better beer by adjusting water hardness. From walls to food, gypsum is surprisingly versatile. It's the mineral you never knew you needed. Gypsum, more than just a wallflower. All right, buckle up. It's time for a showdown. In the world of construction, the materials you choose can make or break a project. Today, we're pitting 3 key players against each other: cement, lime, and gypsum. Each has unique properties, strengths, and weaknesses. So, the big question is, which material wins where? Which one is the right choice for your specific needs? Let's dive into the details and find out. Cement is the heavyweight champion. It's super strong, incredibly durable, and highly water resistant. It's the go-to choice when you need unwavering strength and resilience. That makes it absolutely perfect for foundations, the very base of any sturdy building. And of course, bridges, those impressive feats of engineering that need to withstand immense pressure and the elements. And last but not least, skyscrapers. Cement makes it possible to build these towering giants that reach for the sky, ensuring they remain stable and secure for decades to come. Now, let's talk about lime. Lime is softer and more flexible than cement, offering a different set of advantages. It's ideal for historic masonry work, where its flexibility helps prevent cracking, and for breathable plasters, which allow moisture to escape, preventing dampness and decay. Moving on to gypsum, we find that it is the lightest of the 3. This makes it best suited for smooth, non-structural interior walls, where weight is a concern and extreme strength isn't necessary. Cement hardens through a process called hydration. This is a chemical reaction with water that creates a permanent bond, resulting in a rock-solid structure that can withstand immense pressure. Lime, on the other hand, hardens slowly by absorbing carbon dioxide from the air, a process known as carbonation. This slower curing process makes it particularly great for restoration projects, allowing it to adapt to the existing structure. Gypsum sets by reabsorbing water, a relatively quick process. This results in a smooth, quick-setting finish that's perfect for interior walls and ceilings. Cement shrugs off water, making it ideal for structures exposed to the elements. Lime breathes, allowing moisture to escape and preventing damage in older buildings. But gypsum crumbles and deteriorates if it gets wet, so it's best kept indoors. Each material has a specific niche, a set of conditions where it truly shines. Cement is your go-to for unwavering strength and durability. Lime offers flexibility and breathability, making it perfect for historic buildings. And gypsum is the ideal choice for smooth, lightweight interiors. Ultimately, their unique chemical compositions and properties define their specific roles in construction. Choose the right one for the job, and your building will stand strong and beautiful, truly standing the test of time. That's the essence of smart construction. understanding the science behind the materials you use. So, choose wisely and build strong. What happens when you add water? Chemistry magic. Cement reacts with water to form a dense network of crystals, hydration, making concrete strong and durable. This reaction releases heat, which can be felt in large pores like dams. Concrete keeps getting stronger for months as hydration continues. Gypsum, when mixed with water, reforms its original crystal structure, setting quickly and releasing a bit of warmth. Lime is different. Add water to quicklime, and you get a hot, steamy reaction, slaking. The resulting lime putty hardens only when exposed to air, slowly turning back into limestone. Cement consumes water, gypsum rebonds with it, and lime releases it as it hardens. 3 powders, 3 reactions, 3 building miracles. That's the chemistry behind every wall and walkway. Even ancient materials can get a modern upgrade. Green cement is being developed to cut carbon emissions and even absorb CO2 as it hardens. Self-healing concrete uses bacteria or polymers to seal cracks automatically, extending the life of structures. Hempcrete, made from lime and hemp fibers, is lightweight, insulating, and carbon negative. Synthetic gypsum, made from industrial byproducts, reduces mining and recycles waste. 3D printing with cement-based mixes is revolutionizing construction, building houses in days, not months. New materials like translucent concrete and flexible composites are pushing boundaries. Innovation is making these old materials smarter, greener, and more versatile. The future of building is bright and sustainable. Science keeps building better. Cement, lime, and gypsum humble rocks turned into civilization's foundation. Each has a unique chemistry and a special job: cement for strength, lime for breathability, gypsum for smooth interiors. They build our homes, roads, and bridges, help grow our food, and clean our water. Their transformation is a story of science and human ingenuity. Every sidewalk, wall, and bridge is a testament to their power. As we innovate, these materials will keep evolving greener, smarter, stronger. Next time you see a construction site, remember the science beneath your feet. Cement, lime, and gypsum, the unsung heroes that hold our world together. They really do rock.